Hello and welcome back. Okay, now we this is the second video in this section. Now this is section 2, and in section 2 we are looking at standards of integration. Now in the last video we gave a few of the standards, okay, the ones that are commonly used. Those are the ones we gave. Now in this video I told us we are going to see examples. I'm going to solve 3 examples to be precise. Now these 3 examples are going to cover almost all the standards that I've given to you. Then in other videos to come we are going to look at some other standards. Okay, so let's further. So the first example, they say we should integrate 2x cubed plus 4x squared minus 7 plus e raised to the power of x. As you can see, this is covering about 3 of the standards I gave to us. One of them is for polynomial function, one is for a constant, and one is for the exponential function. So how do we integrate this? So the first thing we have to do, we are going to apply a rule. Is implied. I will imply the rule because I'm not going to state the rule. It's the addition rule of integration, or the addition law of integration. So what it basically does is this. What it states is, whenever you have this kind of expression, what you could basically do is to assume that this is on its own. You integrate this separately, you integrate it separately, integrate 7 separately, integrate e raised to the power of x separately, and that's what we are going to do. Okay, so let's start with the integral of this. When you integrate e raised to the power of x, 2x raised to the power of 3, according to the standard I gave to her, this is a power function. Okay, so what we need to do is to increase the power by 1. So now it becomes 3 plus 1, and we divide by that same power, which becomes still 3 plus 1. Then the same thing, this is still a polynomial function. When you integrate that, you're going to get, you add 1 to the power. This is 2. You can see we are adding 1 to it. We are dividing by that same expression. Then this is a constant. When you integrate a constant, we said you just attach x to the constant. So this is the x that we attach to the constant. And finally, when you integrate e raised to the power of x, you're still going to get back e raised to the power of x. But remember, one thing is missing here. And what's missing here is our constant of integration. So we have plus c. But we don't have to stop here, because we can basically simplify this expression. This expression is not simplified yet. So if you simplify this expression, the power becomes 4 divided by 4. That becomes 3 divided by 3 minus 7x plus e raised to the power of x. Okay, then plus the constant. Now here 2 can cancel 4 to give us a result as 2, and that's the only thing we can simplify more, and that gives us this result. You can see this is the 2 we have here, and this is simply the solution to the first example. You can see integration is quite simple once you understand the basic standards. Okay, it is simple enough. So let's see the second example. This one involves exponential function and 2 of the trig function we discussed, which are the sine function and the cosine function. Okay, now take your time to go through the standards I gave. Okay, if this is the first video you're seeing here, you've not gone through the standards, I'm going to link you guys to the standard in the description. Okay, so after this you can go to the description, where I'm going to give you the link to the video that contains the standard, so that you can reference those standards. And while you're doing this, try to put them down, just write them down. It's not every time you can come back to this video. Okay, so that you should have a jotter where you can possibly reference when you're solving. So let's start. So if I integrate sine x, I'm still going to apply the same principle I applied there, integrating sine separately, integrating cos 4x, and integrating e raised to the power of 3x. So if I integrate sine, what I'm going to get is going to be minus of cos x. If you integrate cos 4x, that's going to give us sine 4x over 4 according to the standard, and then we have this 2 there already. If we integrate e raised to the power of 3x, you have e raised to the power of 3x over 3, then plus your constant of integration, which is that. Now what can go on here is that 2 can cancel 4 to give us 2, And I think that's the only thing we need to do here. Okay, so this is now going to result to the expression. It's going to result to the expression minus cos x minus sine 4x over 2 plus e raised to the power of 3x over 3 plus c. And that's all we have in that one. So this is the third question. The third question is a fraction. So from what we've seen so far, me looking at this fraction, one may think this is quite different from the standards we've seen, because those standards, none of them actually talked about fractions. But this is still a simple case because the denominator is just a single term. Now, since the denominator, this is what you call a rational function. What do we actually mean by rational? The numerator is a polynomial and the denominator is also a polynomial. So whenever you have numerator and denominator of a fraction to both be polynomial, that kind of fraction is called a rational function. So whenever you have a rational function and you're asked to integrate this rational function, if the denominator is a single term, then it's going to be easy. All you need to do is to split this function, okay, into units. So this is what I mean. You split the function to get 4x cubed over x cubed. You have 6x squared over x cubed, x over x cubed, 1 over x cubed. That's just what you do. After splitting the function, now you can integrate each of the parts. After, you must have simplified them. So simplifying in this case, x cubed will cancel x cubed. These two will cancel. When they cancel, you're going to be left with 4. This will cancel to give us x. This x will cancel one of it here to give us 2 of it there. So that will become x squared, and this is going to be left like that. Okay? Now, if you notice, this is a constant. This is looking like one of the standards we had, which is that will result to the logarithmic function. Okay, but let's see what we are going to get. So we have integral of 4 dx. Here what I did was to factor out 6, since 6 is a constant. If you factor out 6, you're going to be left with 1 over 6. So that's the 1 over 6 we have here. Then here, I'll transform this to indices. So 1 over x squared becomes x raised to the power of minus 2. And similarly, 1 over x cubed becomes x raised to the power of minus 3. So now if I integrate 4, it is a constant, so that's going to give me 4x. Integrate 1 over x, that will become ln x. And if I integrate x raised to the power of minus 2, this is a polynomial. So remember what we said, you add 1, the power is already minus 2. So what we basically did there was to add 1 to minus 2. And if I add 1 to minus 2, I'm going to get minus 1. But remember, you still pick this and substitute at the denominator. So that's why I have minus 2 here. The same thing to this, you add 1 to minus 3. Here you already had minus 3. So you're adding 1 to minus 3. So if you add 1 to minus 3, you're going to get minus 2. You divide by minus 2. Okay? So this is what you have. You can see they are quite simple. And then the final solution you have is now 4x minus 6 ln x. This minus will go here. X to the power of minus 1 can become 1 over x. So that's why we got this. The same thing here. The minus can cancel out this minus to give you a plus. And then x to the power of minus 2 becomes 1 over x squared. So that gives us results plus c. And that is the solution to these questions. So as you can see, the process is quite simple and straightforward. So if you have any question based on what I've explained so far, based on these 3 examples I've solved, looking at the examples, it's more like covering almost all the standards I've given to us. Okay, so in the next video to come, I'm going to solve some more examples on this, and then we'll move down to the next section, and